In this video, we are going to be talking about the types of function. In the previous video, we have introduced ourselves to what function is as something that is associated with variables. And we said we have two types of variables, which are the dependent variable and the independent variable, which is y and x respectively. And we also mentioned that y is a function of x. Y is also referred to as range and x is referred to as domain. And we said that we can also refer to x as inputs and y as outputs. Everything is pointing at the y being the function of x, y depending on x. Now, we also explain how to determine whether in an equation y is a function of x or y is not a function of x. And we also explain how to determine the graph of a function, where we are going to be having the x-axis and the f of x-axis, which is also referred to as the y-axis. In this video, we are going to be talking about the bounded function. Let us take for an example. If there is a constant m, constant capital letter M, such that f of x is less than or equals to capital letter M for all x interval, we say that the f is bounded in the above interval, and we refer to this one as the upper bound of the function. Upper bound of the function. So let me write it as upper bound of the function. And if we have another one in such a way that f of x is less than or it is greater than or equals to m, small letter m, we refer to it as lower bound of the function. So this one is going to be lower bound. So if we want to combine these two expressions together, we are going to say that small letter m is less than or equals to f of x, which is less than or equals to capital letter M. Therefore, our lower bound is small letter m and our upper bound is capital letter M. Let us take for an example. Let us say that f of x equals 3 plus x, for example, and it is bounded at between -1 less than or equals to x less than or equals to 1. You understand? Let me write down my very well. So they said it is bounded to -1 less than or equals to x less than or equals to 1. So what they are trying to say is that the lower bound is -1 and the upper bound is 1. So if they ask you to look for the lower bound and the upper bound, it means that we are going to take -1 here. It is now going to be 3. That means f of x equals 3 plus -1, and that's equals to 2. And if you are to look for the upper bound, that is f of x equals 3 plus 1. That is equals to what? That's equals to 4, which means the upper bound is 2 and lower bound is 4. But these x can be any number between -1 and +1, which means in this one as well, what are the numbers between -1 and +1? We have -1, we have 0, and we have +1. You understand? Which means there can be 0 as well. But in this case, we are just looking for the upper bound and lower bound. You understand? Let us take for an example. If f of x, let me write down at the second page, f of x equals 1 upon x, and it is bounded between 0 less than x less than 4. So what we are trying to say is that x start from a number that is greater than 0 and x stop at a number that is less than 4. That is basically what we are trying to say. Because if 0 is less than x, it means that x is greater than 0. That is basically what they are trying to say. So if you say that 0 is less than x, it means that x is greater than 0. You understand? Therefore, an x is less than 4. So the numbers that we're looking for is number that is greater than 0 but less than 4. You understand? So what are the numbers that are greater than 0? 1, 2, 3. And 3 is less than 4, which means in this particular one, in this particular function, these are the 3 numbers that we can have. And the upper bound is, which means f of x equals 1 divided by 1. That's equals to 1. You understand? That will be our lower bound. Another one, f of x equals 1 divided by 2, and that is 0.5. The third one, f of x, equals 1 divided by 3. You understand? So that is how we are going to be having it. I think this one is 0.75 or something like that. So this is a bounded function. This is how the bounded function is being given us. Now, the second one that we'll be looking at is the inverse function. The second one we'll be looking at is the inverse function. Now, how do we solve for the inverse function? That's the question. Now, if a function does something to x, the inverse will undo it. That is what we are trying to say there. If a function does something to x, the inverse function will undo it. Let us take for an example. F of x equals y. You understand? Therefore, f inverse of y will be equals to x. That is basically what we are trying to say. So the inverse is the reverse, like the inverse reverses the input and the output. That is what you have to note. The inverse reverses the inputs and the outputs. Let us take for an example. F of x equals 2x equals 2x plus 3. How do we solve this? There are now steps in solving inverse function. The first step is that you are going to replace your f of x with y. That's your first step. Replace f of x with y. What are we going to have? We're going to be having y equals to 2x plus 3. The next step is that swap x and y. That's the next step. Swap x and y. Which means wherever I see x, I'm going to put y. Wherever I see y, I'm going to put x. Very easy. I'm just going to say that x equals 2y plus 3. You understand? Now, next thing is that make y the subject of formula. The subject of the formula. You understand? And in making y the subject of formula, what are we going to do? We are taking this one back, which means I'm going to be having x minus 3 equals 2y. Divide both sides by 2. Divide both sides by 2. Therefore, my y equals x minus 3 divided by 2. That is basically our answer. Now remember that initially when we started, we replaced f of x with y. You understand? So since we are now having y in this case now, therefore our answer, which is f inverse of x, will now be equals to x minus 3 divided by 2. So whatever your answer you get for y, that is your f inverse of x. That is basically what that is. You understand? Let us take another example. Let us say that we have something like f of x equals 1 divided by 5x. This is the question now. Now, what is the first step that we're going to do? Replace f of x with y. You understand? Therefore, my y will now be equals to what? My y will be equals to 1 divided by f of x. Now, the next thing is that we are going to swap our y with x. You understand? We are going to swap our y with x, which means we are going to be having x equals 1 divided by 5y. And what's the next thing? Make y use of a formula. By doing what? By cross multiplying like that. You understand? In cross multiplying, we are going to be having what? We are going to be having we can just say multiply the both side by 5. You understand? Therefore, my multiplying the both side by 5, I'm going to be having 5x equals to 5 divided by 5 over y. You understand? What's the next thing? Cancel out this one. We're going to be having what? We are going to be having 5x equals 1 divided by y. And if you cross multiply in making y the super formula, my y will now be equals to what? Y will now be equals to 1 over 5x. Therefore, that is my f of x, my f inverse of x equals 1 over 5x. That's my answer. What if we're having a question like f of x equals root of 2x minus 3? For example, we're having this question. How are we going to solve this? The first thing we are going to do, like we do, replace f of x with y. That means y equals root of 2x minus 3. The next thing is that what? The next thing is that replace x and y. You understand? We are going to replace what? We are going to replace x and y, which means I'm going to be having x equals root of 2y minus 3. The next thing is that what? Make y itself a formula. The only way you can make y itself a formula in this case is by what? Is by squaring the both sides. Square this side, square this side as well. So root is going to cancel square. We're going to be having what? X squared equals 2y minus 3. The next thing is that what? Make y itself a formula. That means 2y will now be equals to x squared plus 3. Divide both sides by 2. Divide both sides by 2. Therefore, my y equals to x squared plus 3 divided by 2. So the inverse function is also f of inverse x equals x squared plus 3 divided by 2. You understand? So that is how to solve for inverse function. That's how to solve for inverse function. Now the next one is we have another function here that we refer to as polynomial function. That we refer to as polynomial function. Now, what are polynomial function? That's the question. What are polynomial function? You see, polynomial function are function which are in form of f of x equals a not x is power n plus a1 x is power n minus 1 plus into a n minus 1 x till it reaches a raised power n. You understand? That is polynomial function. They are in form of this. You understand? Where our a naught till a n are constants. And n is a positive integer called power. So that is what we have there for the polynomial function. Now, let's give ourselves an example of polynomial function. Let's say we have something like x is power 3, let's say f of x equals x is power 3 minus 5x squared plus 11x minus 15. You understand? Minus 15. So this is an example, a very good example of a polynomial function. You understand? So we can say that when x equals to, let me say 2, for example, when x equals to 2, what are we going to have? Which means our f of x will be equals to, that is 2 raised to power 3 minus 5 into brackets 2 raised to power 2 plus 11 into bracket 2 minus 15. And that's going to be giving us 8 minus 20 plus 22 minus 15. So if you say that 8 minus 20 is going to give you minus 12, 22 minus 15, that's plus 22 minus 15. And this one minus this one will give us what? Will give us 10 minus 15, and that's equals to minus 5, which means at x equals to 2, our f of x equals to minus 5. That is basically what we are trying to see. And remember that if you are dealing with this, you can also plot the graph as well. You understand? So that is just that one about that one. Now, another one that we have is the exponential function. Exponential function are those functions in the form of f of x equals a raised power x. Given that given that a must not be equals to 0. or 1. I get me. A must not be equals to 0 or 1. This is an example of exponential function. So this is an exponential function. Exponential function. Another one that we have is the logarithmic function. The logarithmic function. And logarithmic function is the one that is in form of f of x equals log a x, given that a must not be equals to 0, 0, or 1 as well. You understand? We also have other functions like trigonometric function that we're going to be using SOHCAHTOA, cot, sine, and stuff like that. We also have the inverse trigonometric function, and some of the trigonometric function that we have sine x, cos x, tan x, and tan x is also equals to sine x over cos x. We have the cot x, cosec x, cosec x, that is 1 divided by sine x. We have the sec x, that's secant x, that's 1 divided by cos x. We have the cot x, that is 1 divided by tan x. We have the sine x squared, sine squared x, plus cos squared x, which is equals to 1. 1 plus tan squared x, that's equals to sec squared x. 1 plus cot squared x, and that's equals to cosec squared x. We also have cos x plus or minus y, which is equals to cos x cos y plus or minus sine x sine y, and so on and so forth. You understand? And so on and so forth. So these are trigonometric function. You understand? And these are some properties of trigonometric function. These are like constants. You understand? We also have inverse trigonometric function as well. For example, inverse trigonometric function like y equals to sine inverse of x. You understand? And this is a bounded function that lies between minus pi over 2 less than or equals to y less than or equals to pi over 2. We also have something like y equals to cosec inverse of x. That is same thing as sine inverse of 1 over x. You understand? So we have them like that. These are inverse trigonometric function. You understand? These are inverse trigonometric function that we are still going to talk about when we get to the concept of differentiation. You understand? So now let us move to the combination of function that is also referred to as the composite function. Now, the combination of function, also referred to as composite function, the function is given by f of x or f of g of x, which is equals to f of g of x. So in this case, we are going to be having the composite of f with g. That is the combination of f of x with g of x. So whenever you hear the word composite function, we are literally referring to the combination function. You understand? So two functions can be combined in various ways to create a new function. It can be combined by adding them. It can be combined by subtracting them. It can be combined by looking for their products or looking for their quotient. For example, let us take for an example. F of x equals 2x minus 3 and g of x equals, let me say, x squared plus 1. Now say that you should look for the composite function by adding them, by subtracting, by looking for the products or the quotient. So very, very easy. What are you going to do is that f of x plus g of x, that will be equals to what? That will be equals to 2x minus 3 plus x squared plus 1. And that's going to give us what? That's going to give us um that's going to give us x squared, right? Plus 2x. So minus 3 plus 1 is going to give us minus 2. You understand? So that is the addition. So the subtraction, that is f of x minus g of x. And that's going to give us what? That's going to give us 2x minus 3 minus into bracket x squared plus 1. Remember that this minus belongs to all of g of x. So that's going to give us what? 2x minus 3 minus x squared minus 1. And that's going to give us what? That's going to give us minus x squared plus 2x minus 4, because minus 3 minus 1 equals to minus 4. That's the second one. Another one is that we can use multiplication. That is f of x multiplied by g of x. And that's going to give us what? That's going to give us 2x minus 3 multiplied by x squared plus 1. You understand? So we are going to be multiplying one by one. That is, this one is going to give us 2x power 3. 2x plus multiplied by 1 will give us what? Will give us plus 2x. Minus 3 multiplied by x squared will give us minus 3x squared. And 3 multiplied by 1 will give us what? Will give us minus 3. You understand? And this is our answer for this one, because there is no one that we can add. So if it is quotient, f of x divided by g of x, that will give us what? That will be 2x minus 3 divided by x squared plus 1. You understand? And this is our answer. There is no how you're going to divide this. It is not going to give you anything. So this is our answer. This is a very simple example of a composite function. How about if you want to form a composite function? For example, let f of x be equals to 2x minus 4 and g of x be equals to x squared plus 3. You understand? So let us find what are we finding? Let us say we are looking for f of g of x. Let's say we should look for this. Let's say that we want to look for f of g of x. You understand? Let us say that's our question number 1. And our question number 2, g of f of x. Please, you have to understand that this one is not equals to this one. They are not the same thing. It's just like this one is wash clothes, wash, then iron the clothes. You understand? Then iron. And this one is iron, then wash. You understand? You know, they are not the same thing. They are not the same thing at all. You are not going to get the same answer. So if they give you f of g of x, it is different from g of f of x. You have to know that. So let us solve the first one. The composite of f with g. That is what we are looking for. The composite of f with g. You understand? That's what we are looking for in the first one. So the composite of f with g, which is f g of x, will now be equals to what? What we are going to take, we are going to be taking the f of x itself. You understand? The f of x. So whenever we see this x, we are going to replace with g of x. You understand? So why are we going to write it? Look at how we're going to write it. What is f of x? That is 2. You understand? Whenever we see x, we are going to put g of x. 2g of x minus 4. That is basically what you are going to do. You understand? So whenever you see x, just put g of x. So which means it is now going to be what? It is now going to be 2. What's our g of x? X squared plus 3. That is into bracket x squared plus 3 minus 4. You understand? So if you open the bracket now, you're going to be having 2x squared plus 6 minus 4, and 6 minus 4 equals to what? Equals to 2. That means our answer is 2x squared plus 2. You understand? And this is our answer. If you now want, you can factorize out. You can factorize 2 out, which means you can say your answer is the function or the composite of f of x with g of x is now equals to what? Is now equals to 2 into bracket x squared plus 1. You understand? So that is what we have here. You understand? So that is for the first one. Hope you understand. Now, remember we said that f of x equals 2x minus 4, right? And g of x equals x squared plus 3. I'm writing this again. So they now say we should look for g f of x. So we are looking for the composite of g with x, like that. It is now going to be what? We are now going to be taking what? We are now going to be taking the g of x, which is this. So what is the g of x like that? It is going to be, now look at it. I told you that we are going to be taking g of x, but whenever we see x, we are going to be putting f of x. You understand? Which means this one is now going to be what? It's now going to be f of x. Then you are going to square it. You understand? Plus 3. And what's our f of x? Our f of x is 2x minus 4. That is 2x minus 4. Then square it plus what? Plus 3. You understand? So if you open this bracket, you're going to be having 2x minus 4 multiplied by 2x minus 4, right? And if you do this one, 2x multiplied by 2x, you are going to be having what? You are going to be having 4x squared, right? 4 multiplied by 2x is 8x. Another 4 multiplied by 2x is 8x. So you are going to be having what? You are going to be having minus 16x. That will be plus minus 16x. Minus 16x. You understand? Then, remember there is plus 3 here. Then 4 multiply. Okay, wait, I'm coming. I think there is a mistake here. Let me write again. Plus 3. Let us reopen this bracket again. Let us open this bracket again. What are we having? We have x times x. We are going to be having what? We are going to be having 4x squared equals to 4x squared minus 4 times 2x is going to be giving us minus 8x, right? Then 2x times this is also going to be giving us what? It's also going to be giving us minus 8x. Then minus 4 times minus 4 is going to give us plus 16. Then plus 3. You understand? So that will be equals to 4x squared minus 16x. You understand? Right? Minus 16x. Then plus 16 plus 3. So 16 plus 3 equals to what? Equals to 4 times 4 is 16 now. Right? 16 plus 3 equals to what? 16 plus 3 will give us, is it plus 3? Is it plus 3 that we have? Yeah, it should be plus 3 now. It should be plus 3. So 16 plus 3 is going to give us what? It's going to be giving us 19. So that is 4x squared minus 16x plus 19. And that's our answer. You will see that the answer for this one, which is 2 into bracket x squared plus 1, is different from the answer for this one. So that is showing you that f of g of x is not equals to g of f of x. And that is where we are going to be stopping for today. In the next class, we are going to be talking about the how to determine the domain and the range of a function. Thank you.